Hey friends, welcome back. Today we learn two specific SQL joins that build big matrices or compare rows inside one dataset. So here is the trick. These tools stop you from guessing and force complete data combinations. Think of this like shuffling two decks of cards and laying every card from the first against every card in the second. You get every possible combination without needing a filter yet. In short, it just multiplies your row counts together blindly. You might wonder why we want everything paired with everything else. This is the standard way to generate a complete matrix of possibilities before you start filtering them. It is the foundation for complex probability or pairing logic. Imagine looking at your own list of contacts and matching yourself to others with a specific relationship. A self join lets us treat one row as the parents and another as the child. Here's the trick. You just give the table two different names in the query. Let's see how we compare the staff table against itself. We look for where an employee ID matches a supervisor ID in that same list of people. Notice how the cross-join concept applies here first, but then we filter to find specific relationships. I once tried to self-join my orders table without aliases and deleted all my sales data. The columns looked identical, so I couldn't tell which was which. Here's the trick. Always name your tables differently before you join them or you will confuse yourself. If you forget to specify which row is the parent in a self-join, you get zero results. If you use a cross join without limits on large tables, your database might hang waiting for impossible rows. Always be careful not to multiply data unintentionally. Here's the difference. Inner joins only show rows where keys match, but cross joins ignore that. Use a cross join when you specifically need every single combination regardless of whether they match on any ID. It is overrated for finding related data, but underrated for testing all possibilities. You can often find the same answer using a subquery inside the where clause. However, self-joins make the hierarchy visible and easier to follow at a glance. In short, self-joins win on readability when you need to see the structure of the data. This is the secret sauce. Self-joins are perfect for drawing family trees or company org charts. They let you connect a boss to their team without needing a separate table for every relationship. So here is the trick. Think of your data as a family tree, not just a flat list. Be very careful because these operations multiply your row count fast. A small cross join might create a massive grid that slows down your next query instantly. Here's the trick. Always put an index on the column you are joining with to keep it fast. We learned that cross joins build exhaustive combinations while self joins analyze internal patterns. Use them when you need to see all possibilities or map out relationships within one source. Clean. In my honest opinion, people use cross joins too much when they should just write a CTE. They are overrated for finding data because they ignore the natural keys we usually care about. Only use them when you literally need every possible pair. I messed up a big report by running a cross join on two tables with 10,000 rows each. My browser crashed trying to render a 100 million row grid without any filters. I learned that you must always add a condition or limit after the join happens. That is all for lesson 13, friends. You now know how to generate full matrices and analyze internal patterns. Compiling takes forever. Subscribing takes 0 seconds.